Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 15, the Homework Solution Edition, in our incredible new tutorial series where you're going to learn artificial intelligence or you're going to die trying. What I'm going to need you to do is pour yourself a nice, enormous cup of iced coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I am going to do today is I'm going to go over the homework solution for the homework that I assigned earlier this week in lesson number 15. Now, in lesson number 15, I showed you about how to do face detection in OpenCV using HAR cascades. HAR cascades, not hard, HAR cascades. Okay, and I kind of went through an example and showed you how to do it, and then I gave you a homework assignment. And that homework assignment was not just do face detection, but to also do eye detection. Okay, if you guys were successful, leave a comment down in the leave a comment down below saying I am legend. And if you were not able to do it, leave the comment I folded up like a cheap Walmart lawn chair. Okay. Hey guys, I really love it too. You guys that are out there posting your homework solutions to YouTube, where you load a screen capture of your program in operation. And what I love it even more is you guys are starting to kind of subscribe to each other's channel, leaving comments about this person's solution versus that person's solution. Really love it, man. Finally getting a little bit of a community going here where, it's not just me talking to you guys, but it's you guys talking to each other. And so I find that really pretty cool. Okay, but enough of this introductory chit chat. Let's jump in and let's look at what we are going to do today. So first off, I will get out of your way, and then we will switch over to a screen view here, and I will need you to fire up your most excellent Visual Studio Code, and we are going to come over here and we are going to create a new program. And so we click the little page icon with the plus sign, and this is going to be OpenCV-22.py, and the .py is pretty important, and boom, a fresh new Python program just waiting to be written. Okay, now we don't want to go in and write that whole darn thing from scratch. We want to start with where we left off last week, where you kind of had your face boxed. It would detect your face and then box your face. And so if you don't happen to have that, you can go to the most excellent www.toptechboy.com, and you can just use this happy little search box to just search for AI for Everyone lesson 15. That's probably close enough to get you here. And you can come down here and click the two little page icons, and darn it, it is not going to work there. Let's see. Let me reload this and see if I can get that. For some reason, well, it's beyond what you really need me to go into, but let's see. It should work for you by the time you get here. Let me come here. Let me try this. Preview. Let me see if I can get one here that has that little icon working. See, I haven't published it yet, and because I haven't published it yet, it is not fully active. Okay, there it is. And I am going to Control-C. Little minor technical glitch there. Okay, we are going to come over here now to the program that we just created, and we're going to Control-V. And then what this should do is this should come in and detect my face. Always like to check it before I move on, making sure the universe is in proper order. And ooh, yeah, I remember this. Remember, I can't use the absolute path because of that space, because of that space in there. And so I need to use a relative path going to the har cascade, the har folder here. All right, this doesn't make sense. Skedaddle on back to the last lesson, and I explained all this there. But let's try to run this puppy now. Boom, universe in proper order. I can copy and paste. Okay, so that is pretty good. What was the first thing that we were supposed to do? We were supposed to instrument this code so that we could kind of keep track of our frames per second. And you guys should know how to do that. But let me go ahead in here and let's see if we can do this. Well, if we're going to determine the frames per second, and I showed you how to do this on an earlier lesson, and so this you should already know how to do, but we'll kind of go through it again. And so we've imported our CV2. We also need to import time because that will allow us to keep track of time. And then what we're going to need to do here is we are going to need to seed our program. We got to go ahead and give it some frames per second just so the program doesn't crash the first time through. So we're going to say frames per second. Let's just say 10, a good place to start. And then we need to go out and snag what time it is when the loop starts. And so we are going to say timestamp, excuse me, is equal to time.time. And what that does is that goes out and grabs the system clock. And then we are going to come down here after we do our facial recognition. And what are we going to do? Let's see, what are we going to do? It should be outside the for loop. And then we are going to say, what should I say here? I should say loop time is equal to the present time, which is time.time minus what? Time stamp. Okay, and now before we do anything else, we ought to go ahead and snag what the timestamp is for the next time around. So then I'll say timestamp is equal to time.time. We're just basically measuring how long it takes to go through a loop, and so I've got to kind of drop a breadcrumb here so that next time around I'll know how long it took. So timestamp is equal to the present time.time. That's just getting queued up for the next time through the loop. So we now have that. And now if we wanted to just figure out the frames per second, we could just say frames per second, but I'm going to call it frames per second FPS new. The new frames per second is equal to 1 divided by the loop time, like that. 1 divided by the loop time. But really here, I want to go ahead and put a low pass filter on it because we know that this thing jumps around a lot. And so I think what I will need to do here is I will need to, let's see. Okay. What I will need to do is I will need to put in a low pass filter. So I'm just going to say the frames per second is equal to, what was it last time? I'm going to say, I'm going to trust the old value 90%. So I'm going to say 0.9 times the old frames per second plus, I don't really trust the new one very much. So I'll say 0.1 times the new one, which is frames per second new. And I have done ad nauseum lessons on making a low pass filter, so you should understand that by now. And I do indeed need to multiply, so I will put the times there. Okay, so now this is going to be our frames per second after applying a low pass filter to kind of take the noise out of the data. And now what I'm going to do is, just to see if this worked, I'm going to say print frames per second, like that. And actually what I'm going to do is, I don't like all those decimal places, so at this point I'm just going to say FPS is equal to the integer of FPS, because I don't care about fractional frames per second. I'm just going to kind of round it for readability. Okay, let's see if this thing is going to run. So I'm going to come here. Ooh, what is this nonsense? Oh man. Time.time is an open and closed parenthesis. Time.time is an open and closed parentheses. It is calling something inside of a class. So we must put our opening and closing parentheses. All right, let's try this now. Still not happy. Line 22, it does not like. What did I do in line 22? Oh, we have another one of those little time.time problems. Okay, now I really think it's going to run this time. Okay, there it is. So you see me, and it seems like that I am running around 10 frames per second doing this facial recognition. Now, what I will, or face detection. Okay, what I will say though is that the reason this is running relatively slow for me, I've got a blindingly fast computer. I am running my studio and my Wirecast and all of that is recording this lesson for you on this same computer. And so that uses up a large amount of my video processing resources. And so it's hard to run Wirecast and this OpenCV at the same time. You should be getting better results than this. When I run it without Wirecast, I'm getting like 25-30 frames per second, but I digress. So we have now instrumented the code, but what I think I want to do now is I want to put the frames per second on the frame. And so what we could do there is before we do the IM show, what I could do is a CV2.put text. Okay, I'm going to put the text where I am going to put the text on frame. Okay, and then what I want to do is I want to take the string. What text do I want to put there? I want to take the string value of frames per second. Why? Because you can only put text to string. Frames per second is an integer, so I got to change it to a string. And then a little nice formatting. So I will concatenate with a plus. I will concatenate with a space. Frames per second. Now, if you really wanted to be good, you would draw a solid color, a solid complementary colored rectangle behind the text that you're putting on there. But I've done that so many times before. I don't want to slow you guys down. I want to get on with the main point of this lesson. So we're just going to kind of wing it and not be snazzy and put the rectangle behind it. But okay, so we have done that. Now, where do we want to put it? Well, I'll put it it's an XY. I'll put it over 5 and down. Let's see, I'll put it over 5 and down about 30. So over 5 and down about 30 should be on there pretty good. I got to give it a font, so I'll say CV2.font, and let's say font Hershey Plain looks good like that. And I had better scroll up a little bit so you can see. All right, you can see that pretty good, can't you? Okay, so I've got my font in there. Now I got to give it a size. I'll give it about a font of 1. Let's give it a color. Let's see. Let's make it blue. So that will be a tuple of 255 for blue. Well, let's see. Yeah, we'll do that. 255, 0, 0. So the blue strength is 255, the green strength is 0, and the red strength is 0. That should be a nice bright blue. And now what I need to do is I think that I need to give it now, how heavy of a font do I want? And I think I'll give it about a 2 like that. All right. Were you able to see all that? I think you could probably see all this. So now also I can make your life a little easier if I get that out of the way. So now let's see if I've got instrumented code with the FPS displayed on the frame. I do think I do. Although I hate, oh, boom, look at that. But that's a wee little font there. I think we need to make that bigger. So that is, let's see what happens if we make it a 2. Come over here like that. I made it a 3. That's too big. Quit. Let's make it what I really wanted, which was a 2. Okay, let's run it. Boom, that looks pretty good. I am so obsessive compulsive. I think against a green background, it would look better yellow. And so that would be blue, green, red. And so we are going to make blue 0. We'll make green 255. We will make red 255. That should give us yellow. And let's make it a little heavier at a 3. I don't know why. I feel like I have to tweak these things to perfection. And of course, now we need to go back to a 2. So looks like 2 is the right thing. I promise I won't play with this anymore. We'll get on with it after this. Okay, boom. Look at that. That is very strange what that's doing there. I do not know why it's doing that. But we're operating now. That put text seemed to really slow us down some, but we're coming back. Okay, let me quit there. Why is that showing those gray frames on there? I do not know. The frame is staying the frame. I am not exactly sure why it's doing that, but again, I'm getting these glitches because I'm using up my video processing power trying to run the studio, but we will trek on and hopefully it won't give us too much trouble like that anymore. But we did the put text there, and then now that we're doing the put text, we don't need to do the print, and so we'll take that out. All right, like that. Did that really slow it down that much, that put text? Let me try this again. Yeah, that put text seems to be using a lot of resources. Let's see. Okay, I'm holding at 5 to 10 frames per second, so we're going to move along with that. You ought to be doing a lot better than that. You ought to be doing a lot better than that. So now we are going to need to do what the assignment was, which was find the eyes. And I'm going to do it probably the way that you were doing it, and then I'll show you kind of the way I do it. And so sort of the straightforward way that you could do this would be to come up here, and when you create your face cascade, you are also going to want to create a what? An eye cascade like that. And then we're just going to copy this, and then we'll make some adjustments to it. Copy and then paste. So we're going to create an eye cascade. You guys probably played around with your hard cascades, and you probably saw that there is one that is called eye. Okay, there is one that is called eye. So I am going to right mouse click on that. You probably could use the copy path, but I'm going to copy the relative path because I've got that space in my, I've got that problem with that space in my username that OpenCV doesn't like in a path. So now I'm going to Control V, and so now I've got my eye cascade there, and I had better get this up. I had better be mindful to make sure that you guys can see what I'm doing. Okay, so now I've created an eye cascade along with my face cascade. And so what you could imagine is a pretty straightforward way to do this would be that if I just grab this code, okay, like this, okay, and then I came here, and then if I pasted, okay, and then if I said for, let's see, and then here, what I'm going to do is instead of creating a face cascade, I'm going to create an eyes cascade, and the eyes cascade is going to be, instead of face cascade, I'm going to use eye cascade, which we created up here. Okay, so I find the faces, and then I box them. And now I'm going to find all the eyes, and I'm going to box them. So now instead of face and faces, it is going to be eye in eyes. Okay, and then XYWH is not going to be face, it is going to be eye. Okay, and then I'm going to put a CV2 rectangle. That looks good. Could it really be that easy? Could it really be that easy? We're going to find the eyes, and then we're going to see if we can track them. Okay, let's see what happens here. How many crazy mistakes did I make? I don't know. Let's see. Okay, let's see. I will tell you that it doesn't like glasses. But boom, look at that. Okay, look at that. And it actually got a pretty good frames per second there too. Okay. And for some reason I have it doesn't like my one eye very much. Okay, but you can see that it's working. Okay, boom. So it really was that easy. But let me tell you something that you got to see here. These detect multi-scale, this iCascade detect multi-scale, that is a very, very computationally intensive. That is a very, very computationally intensive step. And it has to look all over the frame to try to find an eye. So it is scanning this big, huge frame trying to find an eye. Now, if you're on a laptop doing this, it might have already bogged you down to look for the face and then look all over the whole picture for an eye. So this is what you got to think about, because if it hasn't bogged your computer down in this lesson, in future lessons, your computer is going to get bogged down. So you got to think about computation resources when you're doing this artificial intelligence. Tell me something that is always true about the eye. Almost always true about the eye. Class? It is almost always on the face. Like, you don't have an eyeball floating out here in space. And so what would be a way that we could do this? What would be a way that, let me turn that darn ringer off. Okay, what would be a way that we could do this much more effectively? Okay, well, what we're going to do is we're going to get rid of all of this that we just did. We're going to get rid of all of this. And now what we're going to do is we're only going to look for the eyes on the face. We're only going to look for the eyes on the face, and then it can just scan that little region and it would go a lot faster. Now, because my system again is fighting with the studio software, we might not see it. We might not see it as dramatically, but hopefully you'll see a dramatic improvement at home. So what we're going to do here is that, you know, we do the 4 face and faces. What we're going to do now is we are going to come in here inside the loop. Okay, we're going to come in here inside the loop. And what we're going to do is we are going to create a region of interest. So I am going to say that frame ROI, do I even need that? Yeah, I'm going to create a frame ROI, a region of interest, and that region of interest is going to be in grayscale, and that is going to be what is my region of interest. Let's see. Let me start by creating a frame ROI. Okay, and the frame ROI, the region of interest of that frame is going to be just the face. Okay, it's going to be just the face. Well, what is that? That is going to be the frame. And what part of the frame are we going to be looking at? Just where the face is. Well, where is the face? Well, remember we go rows, comma, columns. And what is the range of rows that we want to look at? Well, we want to look at the Y value that we just got, and we want to go to Y. We want to go from Y to Y plus H. Okay, and then we're going to go from X to X plus width. So you've got this frame. Okay, you've got this big frame, and then we found the face, and the face is at XY, the corner, and then we want to go from the XY down to the X plus width and Y plus height. But remember, it starts with rows and then columns, and so that's why we go Y, because Y's are the rows. Okay, so now I have a frame ROI, and now what I'm going to do is I'm going to create a frame ROI gray, and the frame ROI gray is going to be equal to CV2.CVT color. And then what do I want to convert? Well, I want to convert frame ROI. And then what do I want that to be? I want that to be a CV2.CVT color. And then what color? I already did that. I'm sorry, CV2 color BGR to gray. Okay, so now I have the face and I have it in grayscale. Okay, so now I've got something that I can actually work with here. Okay, so now I have that. And then what I want to do is, I've got a frame ROI gray now. So now I want to find the eyes. So I'm going to say eyes is equal to what? I cascade, right? It's I cascade. And then what do I want to do? I want to detect multi-scale, all right? But where am I going to do this on? I am going to do this on what? Frame ROI. Great. So what am I doing now? I'm looking for eyes in this little box that has my face in it. I am looking for eyes in the little box that has my face in it, instead of looking over that whole huge frame. I hope that makes sense. Now what do I do? Inside the loop that finds the face, inside that loop, I find the eyes. And if there's no face, there's no reason to look for the eyes. And if there is a face, there's no reason to look everywhere. You only look inside that face, if that makes sense. So now what do? I say, well, for I in eyes, now I'm going to say like for I and I want to do, let's see here. Let me think for a second. Okay, I'm going to have to still keep my old X and Y. I still need to know where the face is. And so now what I'm going to do is I'm just going to come in and I am going to say XI, comma, YI, and then comma, width of the eye, and then comma, height of the eye is equal to I. And this is completely analogous to what we did up here, but I just don't want to write over these variables, so I might need them. So I'm creating a new set of variables, xi, yi, width of the eye, height of the eye, and that comes from that array I. I hope that makes sense. Okay, now I've got to put my rectangle on it, wherever it's found. So that's cv2.rectangle, all right? And now where do I want to put it? Well, I want to put it on frame, okay, but only a part of the frame. What part of the frame? I'm wondering if I could use, no, I'll just do it this way. What part of the frame? Well, where my face is. Where is my face? I could probably copy this up here, yeah. Okay, so do you see what I'm doing? I am putting a frame on inside of that region of interest, okay? So what I'm passing it is not the whole image. I'm passing the rectangle, just the little frame, just the little face, okay? And so I'm passing it the face, which is this part of the whole frame, okay? Now, what do I want to box in there? Well, I want to box xi, comma, yi, and then comma, x, do I do that right? Yeah, xi plus x, or width of the eye, and then comma, yi plus height I. Okay, does that make sense? I hope it does. And then I'm going to need to put some other things in here. What I'm going to need to now put is the color, okay, and the color is going to be 255, 0, 0, and then I need a line width, and I'll put it at 3. Okay, so what is the trick that I'm doing here to make this run faster? I don't need to look for an eye if I don't have a face. And then if I have a face, I don't need to look everywhere for the eye. I only need to look for the eye in the face. So in my detect multi-scale, I only look at the region of interest, which is the face. Okay. And then when I put the rectangle, I don't put it relative to the whole frame, but just that little part, that region of interest that I had. Okay, that region of interest that I had. Oh man, I know. Oh man, I know I made mistakes in here somewhere. But let's look and see what happens when we do this. Is there anything else that I need to do? Now let's just try to run this and then find all my mistakes. Didn't crash. Let me take my glasses off. Boom. Shazam. Look at that. Okay, it is finding my eyes. And yes, it is going slower this time than it was before. But again, that's just this goofy business. You guys leave me a comment below. When you do it, are you finding that it speeds it up when you're not looking at the whole, thing? So let's look here. Let's see. That is working really great. That is indeed working really great. I'm going to stop this. I'm going to try to run it again. Okay, boom. Now look at this. That's pretty respectable, but it's going down. Okay. Oh, it found the same eye twice. That's unusual. There it is. Okay, guys, look at that. That is pretty darn amazing. So even though the thing didn't show up the way it should have, I think on yours you should see that this is a lot faster because it doesn't take much computation resource just to snag a region of interest, and then you're only searching over that region of interest. You're not searching everywhere. I think there was one other thing that maybe helped me before a little bit. When I do, what I wanted to show you here is I should probably say something about this. When I did the eye cascade to detect multi-scale, I didn't put these parameters in because I just found for the eye using the default parameters worked better, and that's why I did not put the other things in there. You can play with those parameters and see if you can get it to work a little better, but for me, I found that it worked the best just to use the default parameters. All right, guys. We are really getting into it now. We're not only detecting faces, we can detect eyes on faces. Now, I am sure some of you more show-offy or more, kind of like self-directed guys probably saw that there are a lot of different hard cascades here, and one is a full body. Like if you have it pointed outside, you can find people, like a person walking by, you can find the full body. It'd be kind of interesting. I just don't have a good thing that I can show a bunch of people walking by, but maybe if you count, like if you found people in a picture and then counted how many there were, so it would be like for body in bodies, and then count how many bodies there were as you're going through there. And so I'm not sure what eye tree eyeglasses is. Maybe this finds eyeglasses or helps you find eyes behind eyeglasses. You have frontal face extended. That's maybe an enhanced model for finding your face. Frontal face, we use frontal face alt. Then we've got frontal face alt 2. So they've got different models in here, and you can play with them and see which one you like the best. I think we used the frontal face default. And then it has like it has like a left eye. It only looks for left eyes or only looks for right eyes. That might be interesting to do as well. And then let's see, recognizes license plates. And so if you had cars go by, you could track and identify the license plate. Lower body, I don't know why we would want to do that. Profile face. So remember that as we turn our face, it loses the ability to find the face. Well, you could say, you could also look for side faces as well as frontal faces. And then for our Russian friends, our Slavic friends, we could look for Russian license plates. Also, we have a smile detector on here. And so and I can't really demo this very much because I don't smile very much, but if I do smile, my beard makes it a little hard for it to find the smile. But what you can do is you can try this out. You can just be sitting there and then you can look for a smile. Would you look for the smile on the whole image? No, you'd look for the smile on your face. And then likewise, we have an upper body detector. So we've got some pretty good stuff to play with. So I'm not going to give you a homework assignment because this was the solution to the homework assignment, but you guys can go out and play with these hard cascades and you can have some fun. And remember, post your your solutions on YouTube down into the description of your video, link back to this lesson so anyone watching it has context. Then leave a comment on my video with a link over to your YouTube video. And then you guys continue to subscribe to each other's channels and then look and comment on other people's solutions. You know, again, develop a little bit of a community here. Okay, guys. I hope you're having as much fun taking these lessons as I am making the lessons. Next week, we'll get into some more interesting stuff. We'll just sort of continue to move forward and move to more advanced things. One of the things I'll tell you that I'm really thinking about is I'd like us to I'm debating this, I'm pondering it, so I need your feedback. I'd love to show you how to build a little pan tilt system based on servos, and then have our Python talk to Arduino, and then Arduino control the two servos on the pan tilt bracket, and then mount the camera on the pan tilt bracket, and then have the camera actually track you or track an object of interest. So to do it, we would have to buy two servos. You would have to buy the pan tilt bracket, and then you would need an Arduino. And so let's say most of you probably already have the Arduino, or most of you already have the Elegoo kit. And so an Elegoo kit is about $35. I think the servos, this is the problem. You can buy the servos for just a few bucks, but the ones that really last and the ones that really work well are the high-tech servos, and they're about $16 each. So it'd be 16 each. Two servos would be 32. The bracket is about $10, 42. And then if you don't have the Arduino, it would be 35. And so under $100, you could get all the hardware where we could really be doing some neat stuff. Now, this is what I struggle with is that some people don't have the resources to buy that stuff. And if I start doing things that require you to buy stuff and I lose half my audience, that's not good. Okay. But at the same time, if you guys that have a little bit of resources, like under $100 to buy this stuff, then we could do some really neat things, because we're not just looking at what's happening in the frame. We are tracking things by moving a camera around. And I think that would be pretty neat. So leave me feedback below whether you guys would like me to move forward with these lessons, not requiring the purchase of new hardware, or if you would be willing to purchase some hardware. And maybe if we did these hardware lessons, you guys that can't get the hardware could just watch, and then we will have a lot of neat stuff that you're going to learn that you can still do without the hardware. So leave me some feedback down below. Okay, I've done a lot of chatting here. I think it's time to wrap up. So this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.